In this video, I'm going to use EasyEDA Pro to create a small PCB that leverages this microchip AVR64DU in a 28-pin DIP package. And I've put a blog post out there, and you can jump over to this blog post if you're interested. I'll be building this out, I guess, as I go, but I've started to capture some information. But basically, this goes back to a request. I had done a video on using EasyEDA Pro, and I did a small little BGA type of chip. Requests had come in, could I maybe do a walkthrough of purely a through-hole type of project, and a single or double layer maybe is the target instead of having a 4-layer type of board. And thinking through that, I didn't necessarily have a specific IC in mind that I was going to use, but I thought I would just pick something I've never worked with before, and I did a little bit of searching, and it seemed like this AVR64DU is a relatively current, basically microcontroller or MCU, and that's what I'm going to use. So maybe to give a little background on this, what I am going to come in here and talk about is, kind of what is my process, and you can read about this here, but, step one, what's my goal? And so really what I want to do is be able to maybe have a little video that's a tutorial for those of you that want to use, this specific EasyEDA Pro. Or maybe you're just interested in this specific microchip AVR64, and maybe you'd find this interesting too. But that's my secondary, purpose here. It's more about how would I go through the process of building a PCB for this specific chip. And if I talk about some of the requirements or how I'm looking at this, I want to build the schematic and the associated PCB in EasyEDA Pro. There are many choices out there, but this is one that I've been using, so I'm going to talk through it. If you want another option, maybe KiCad is an option for you, or if you want to go to something that's more of a paid professional type of tool, maybe Altium or other types of tool sets would make sense. I am going to try to keep this exclusively to through-hole components. I do know that's going to limit what I can do with this circuit, because I'm finding that a lot of the components I would really like to use are only in surface mount at this point, so that will impact the design, but I'm going to try to keep it entirely through-hole and not do any surface mount. I want to use a 100 millimeter squared board or less, again, 2-layer. And I'm picking that size because as I work with JLCPCB, that's normally who I go to have my boards built. That size is kind of the limit of the less expensive boards. And I'm going to do my best to find components that are commonly available as I get into this. So what I've done is I've listed out some resources. There's a data sheet that is going to be helpful, and I can maybe pull that up in a separate window here or a separate tab. And so this will get me into the details about this specific IC. Maybe I'll come down and just look at maybe something real high level, like here I have the pinout that I'm going to have to work with. Other things, there is a document on EMC design considerations. There's also hardware design considerations. And there is a reference board out there that, if all you're looking for is to get in and play with this specific microcontroller, you might want to just come out here and purchase one of these Curiosity Nanos. It's essentially the same chip. It's a 32-pin, a different package, not a DIP package. But if that's your goal, is just to learn about it, I of course wouldn't necessarily bother with building a PCB. I would just go out and buy one of these and experiment with it. But it does have a lot of nice reference design that we can look at and see, what are they doing, and are there things that would inform my design. My first step is to kind of sketch things out, and that's what I put in here is like, okay, I started with something that looks like this, and just grabbed a piece of paper, and I read through, maybe some of this documentation like this here, and just jotted down some notes as I was going through that. And the point here isn't for you to read through all these notes. It's just the idea, though, that, I kind of just started with a document, and then I worked my way through it and maybe did a little bit of other reading, but I jotted down key things that I want to pay attention to. Maybe up here I'm talking about how I'm going to maybe bring in power, talking about decoupling caps on the different VDD pins. What might a reset circuit look like? What about crystals or oscillators, things like that? how am I going to program it? There's a couple different styles of programming ports. And then I just started making a checklist of all the other things I need to consider. And you probably can't even read my writing. So again, the point is I'm just showing kind of the process. And from the specific documentation to that data sheet, there was also one of the pages I printed out because it talks about what are all the different pins. And this might be hard to read. And I don't know if I can zoom in on this very well. No, I can't. In this, there is a listing of the different pins. And so this column here happens to list out the pins for the package I'm using, this 28 pin dip. And then off to the right, there's a bunch of different types of functionality, and they show the columns and then maybe what pins need to get used for that. What I simply did is I scratched out the columns that don't apply to this package I'm using. And there are some pins that this package doesn't have, so I just marked those as not available. But then I just kind of highlighted what do I want to make sure I'm using those pins for. So for example, this again, this isn't going to be readable in the video, but pin 24, I'm going to connect, which is also named PA2, and I'm going to connect that to a switch, like a switch that I can flip left and right type of switch. Pin 25, I'm going to connect up to a momentary type of switch, or what I'm just simply calling a button, so a momentary type of press it and hold it type of button. I have a couple other pins that I'm going to hook up for a potential of a high-speed crystal, and also hook it up for a serial transmit and receive, so that the board will support either. I can either use it for a serial connection or I can use it for a high-speed crystal, but not both. And then the rest of these, I think I've just got one thing selected. So I've got some pins here that are going to be for SPI. I have some pins here that will be for a USB, basically a USB connector, so that this little board can act as a USB device if I plug it into a USB host. I have a pin that I'm going to pick for an LED. I have a full 8 bits here that I'm just going to leave as an open header, so I can do whatever I want with it. I've got some powers and grounds. I have a low speed crystal. I have a reset, and I have a programming type of signal. It's a single wire programming. But I use this just to kind of center myself on, as I start to lay out the board, what am I going to try to have hooked up as I go? And that thing gets me to where I stopped on this blog post, which is, okay, let's now try to build this out in EasyEDA Pro. Now I'm going to throw out some cautions here. I'm going to go through this not having built this yet. I've not laid out the schematic in EasyEDA Pro. I don't know exactly which components I'm going to select as I go through it. So if you're interested in me going through this, this is essentially me going through this and trying to figure this out as I go. Which means it might be a little bit longer video than if I had it all previously pre-built and I'm just reinventing or repeating what I've already built. So there'll be some, I'm sure, editing here as I'm going to go do research and have to come back, but hopefully it'll give you the idea of how am I thinking through this. So I'm going to pull this to my other screen, and on my screen that I'm recording, I'm just going to pull up EasyEDA Pro. And probably the first thing I'm going to do here is create a project, and I kind of have somewhat of a folder structure over here that I've been using, but I have a folder called MCU, so I'm just going to create a new project. So I'm right-clicking, create new project, and other projects I've done like this I've labeled as MCU, dev board, and then what kind of board is it that I'm working on. And so in this case, I will put in the microchip AVR64DU28. Step one then, probably once I get into this, is to open up a schematic. I typically change the size of my drawings. So this is an A4. I might go out and look at like a B size that is an 11 by 17. So for me, that works pretty well. And I'll just use that as my drawing size, and I'll save that real quickly. This button up here lets me add components, and you can also hit Shift F. But if I click that, I probably want to see, is there an existing component I can just use for an AVR64DU? And I'll just start maybe with an AVR64DU, do a search, and see if it finds much with that. And it looks like nothing. Maybe I'll back that up and just say, well, search for an AVR64. And it looks like I found a whole bunch of things that start out with that, but they're different lineups in the family. There's a DB, a DA, an EA, and they're maybe not the 28 millimeter or 28 pin 300 millimeter through hole. So I'm going to pick that and apply that filter. And it looks like there's only two here, and there is a DD and there is a DB, neither of which is exactly what I need. So what I might want to do then is decide, do I want to make my own or take one of these, and it's probably generally close, and then edit it for my purpose. And I could go either way. Now, if I'm doing this, for me, for real at this point, I'm going to just simply pick, one of these that is more of what I'm looking for. So if I look at these, let me just pick one of these. I'm going to grab this DB. So if I go ahead and place it, I would get something like that. And I just want to kind of see, what does it have, I guess, for a 3D? Does it have a 3D model that comes with it? So I'm going to quickly save with a Control S. And then I'm going to come in here, and in my design, I can say update, convert that to a PCB, or I can hit Alt-I. And I've just kind of gotten used to hitting Alt-I, so I don't hit the menu often for this, but that'll just simply start building, what my PCB might look like. So there's my IC that I'm going to center everything around. And I'm curious what the 3D looks like if this specific IC has a 3D on it. And it does. So, okay, that looks good. I'm just going to use that. And so I'll get out of my PCB for the moment and get back to my schematic. Now, something else I need to compare with, though, let me pull this up on this side. And just get some of these out of the way for the moment. I want to compare that with what does the actual chip I'm using have for pinout. And I'm going to pull that back onto the screen. So this, again, is the data sheet, and it's going to be similar. And I can see, looking at this, it is quite similar, but there are some differences. So this next one, this next pin at least, says PC0, where this one over here says VUSB. And I do know I'm going to use these for USB, so I probably don't want to call it PC0, PC1, PC2. Now there is in here this sheet, so I could go look at, if I look at my USB signals, first of all, I'm looking at this column. This is my 28 pin column, USB, and here I can see that their pin names are this. So they're not, they're not PC0, PC1, PC2. It's what you see right here, which just tells me I want to stick with probably these names. And so I can come over here on the left and just double click on this. Actually, I need to right click and choose Edit. So I'm going to edit that device, but now I can double click on this and rename it to VUSB. This is my data positive and negative for my USB. PC3, and then this, that'd be a big difference, is a PD0 versus power, whatever it was before, 1, 2, 3, 4, 5, 6, 7, VDD. I don't have an analog VDD, so just VDD, make sure that's labeled correctly. 6543, PA1, XTAL, HF2, HF, ground, VDD. This is a PF7. I'm just going to make this match exactly. So PF7, well, actually in my case, I am going to use it for UPDI, so I might just leave it to say UPDI. And then I am going to use this for a reset in my case. And then I have PF1 and PF0, which would be for my slower, low-speed crystal, which I am going to use it for that purpose dedicated. So I'll just rename it like so. Okay, so I have something that looks like that. And I'll go ahead and save that. And maybe let's see what I have for options. I can save as, okay, let's just do a save. Now in my library down here, I can go look and say, well, for this project now, I have this specific chip in here that is part of my library. And I can look at it over to the right, and it's really small, but I can see it does have the right name in that. And I can also click down here to preview the 3D. Okay, so that's this chip, and I am fine with that. So I'm going to close out of this. And this is what is now going to be the center of my project here. So then I have to think through what are the pieces. And if I go back over here to this page, I had just posted, just so you have an idea, my notes that, kind of walk through what it is I want to be doing. And I'm going to kind of use this as my own reference. That's why I went through and did this. But I can decide, how do I want to power it? And I'm going to offer 2 ways to power it. And one is going to be a USB connector. One is going to be a barrel connector. So I might need to come in here and find a component and see if I can find like a DC barrel connector and look through, some of these, I'm seeing I don't have pictures for a lot of these, which isn't so helpful, but I might come in here and just search, connectors and see if I can find it. Now, one thing I've noticed is, this stuff is not alphabetically ordered, which is completely unhelpful. I don't think I can change the order of what's here, or I've not seen a way to do that. So I don't understand the logic there of why this is just the mess that it is. So if someone does have a tip there, do let me know. But if I pick DC power connector, which I just happened to see and click, now it gives me a bunch of different choices. And all of these are probably pretty comparable. Now, what I've found is, especially if I do eventually want to have, let's say, JLCPCB assemble it for me, it's very nice at this point to pick a component that they have a part number for and that they have in stock. And so some of these I can see they have lots and lots in stock. Almost all of these, they have a lot in stock. So I've got a lot of choices here. And if I look through these, they're all probably pretty comparable. And I might look at price. So we got 5 cents, and these look like, maybe I'll sort it by price. So here's the least expensive. That's not a style that I typically look at. I don't like that. So here's one that is stocked. They have 7,700 of them, and it's 2.6 cents. So I will pick that one, and I'll do a place. And so now this is my DC barrel connector that I'll get to work with. The alternative is I could bring power in maybe through a USB connector, and eventually I'm going to hook up a USB so that it can be also treated like a USB device. So I might search here and look for a USB-B connector. Let's just see what we can find here. And I suppose actually I could use USB-C. Let me do that and see if I can find a through-hole version. Let's see if plug-in here will give me some through-hole options. Again, I might, I'm sorting by price, it looks like. And this one I can't quite tell. Let's see if the data sheet works. And that does appear to be a through-hole. And there's a data sheet. Let's see if that does work. Okay, it does. Perfect. So I think I'll pick this one, at least for now. So let me go back, and so I will place that. And this will be one that I'll have to connect up over here eventually. But I think at this point then, this could provide me power coming in as this could up here. So I might go grab, let's just say a little pin header. And let's see if we can find a 1x3. And I think actually there's a whole category over here. So I'm going to go with a male header. Okay, pin header. I can scroll to the right. Lots of things I can filter on. And I want to go pick a 1x3. So there's a 1x3. And there's a simple pin header. And go like this. Okay, so maybe to get me started, and this I'm going to keep changing as we go, but for now, what I might want to look at is, okay, let's come in here and let's see, this should be the positive. So I want to draw a wire. Now, a couple ways to do that. I can just hit Alt-W, and then it lets me start drawing a wire. I can also come up here, probably under Place, and I can do a wire, or I can click this in the toolbar. And so I'm just going to hit Alt-W. That's the normal way I do this. And a couple of things we've got that I need to connect up is if I'm going to pull power, let's see, I should also double check what is VUSB. And I can come over here and I can search for VUSB. And I should be able to find a signal. Okay, power is the USB peripherals, internal transceiver, connect to 2 pins DM and DP. Okay, so then as I read through this, then they give me some choices. How do I want to connect all of this? And they're showing that I can either go off of, they describe this first of all in the document, but how do I want to pull power? Do I want to pull power from this DC barrel connector to power my system, or do I want to pull it from the USB-C? For power source, do I want one to be more important than the other, but both are usable? That's what these combinations are. And I'm going to treat it like, this first one is let's see. So this is a 5S, and they talk about a local 5-volt source is connected. So they're showing a local 5-volt source comes into VDD, and you run this VUSB to ground through a capacitor. That's what I'm going to support, along with this one over here, powered from USB. Now, the smarter way to do this is to maybe support both and have one of these things called an SRLC that basically lets it, grab power from whichever and bring it through. And I did a quick search for those, and they're all the ones I found are little BGAs, surface mount. Doesn't fit my through hole goal of sticking with through hole. So because of that, I think I'm just going to do this idea where I come into this pin header, and maybe I will rotate it like this, but I might bring power over here to VDD. And it looks like I have a second VDD over here, which for now I'm just going to run it around like this. And then I'm going to bring in this VCC, and maybe I'll rotate this. So I just selected it, I hit the space bar to rotate. I hit it twice, and then I'm going to go back to Alt-W, and didn't quite like that. Undo. Oh, sorry, right here is the one I want. I will go like that. And then this, maybe I'm going to just drag out of the way a little bit, and I don't need that big long name anyways. I might just call it DC barrel. And this is my barrel connector. And I will grab power from it and go like that. And then these two should be ground if I remember right. So I'm just going to click and connect through those. And I'll need to grab over here. There's analog ground, there's P ground, and a ground. I just want plain old ground, so I'll put that in there like so. And then I might just copy paste and put another one of these in for this one. And you can choose your style. Do you want to have separate grounds or connect this up to the one above it? I'm just going to go like that for now. And maybe I'll even come further out to bring this over here and go like that. Okay, something like that. So what this is going to let me do is I can either bring power in from the USB and jumper it here, or I can bring power in from DC barrel and jumper it here. So I'm going to have a jumper to let me pick which of these two is going to be my power source. Then there's also, these, this is the shield. I'll come back to that grounding a little bit later. And then I'm going to have some data signals, and we're going to have to connect that up in a little bit. And actually for now, if I want, I could just start to connect that. And I clicked the positive, so that's going to come here. And then the negative is right above it. And so, I might have something that looks like this. Now in time, we'll want to figure out, how do I, like if I don't want this to cross, if I don't need to, so can I just bring this down here? Maybe I would take this, select that, delete it, rotate this, bring this up here. And the bad thing about that is that might be confusing. I might flip that back, but I'll go like this and just say, okay, let's connect that in like so. And then I'll copy and paste out my ground. Okay, so maybe something like that. So I've got my ground of my DC barrel. I've got the inner pin, which should be my positive. I can either run that in or come from the USB-C connector and then run that to VDD. Again, I've got more stuff that's going to have to come in here in time, but maybe that's how I start this out. So I've got a USB connector. I'll have to figure out this ID. I don't think is going to go anywhere. So for now, I'm going to pick up this, which is a no connect flag, and just say it doesn't connect anywhere. And I know at some point I need to do something different with this shield, but maybe for now, just so I don't forget to hook them up, I could at least maybe put in a ground here, and I'll go like that. There's actually going to be something else I'm going to want to add to that, but good enough for now. And I got to remember to be saving as I go, so I'll hit a quick save. Okay, so that got me VDD, which is my positive power coming from the middle of this pin. Now these can take plenty of power for what this little circuit's gonna be able to drive or pull, so I'm not worried about that. Let's see, this VUSB then I had to run through a capacitor to a ground. And if I go back to my notes, there's probably some different notes that I could put into this as far as what should that look like. Back over here, they show a capacitor going to ground. And then the question is, did they specify what that should be? And I'm just looking to see if I had put in a note on what that capacitor should be. So this would be for this VUSB. And I'm going to see if it says anything here about what the capacitor should be as far as that connection to ground. These capacitors here I did make note of, so I have that. And maybe for now it's not going to make a lot of a difference, but I'm just scanning to see if I can quickly find what that capacitor V or C VUSB. Okay, so for now I'm not seeing what that capacitor should be spec'd at. But what I might then do, and I could keep digging through the document, there might be something in there somewhere, but maybe I will come over to here and I'll go back to this nano example and just see what their schematic looks like. So I can download and open this, and they do give a schematic. And what I'm going to essentially look for is, did they connect this VUSB to ground through a capacitor? And so we get something like this. They might not be, let's just see, what do we got here? VUSB, and then you can see here they're taking it to ground, and they're doing a 0.47 microfarad. So at least for now, that's what I'm going to go with. So a 0.47 microfarad. I need to now come in here, and there is a common library over to the left. And so then I can pick, what do I want here? And I am going to pick, these are going to be surface mount. So I think just looking at all of these I'm going to guess are all surface mounts. And, I could probably pull one out to take a quick look at it. But if I pick one of these capacitors and I bring them out, and let's just say I want to hit save, Control S, and then I'm going to hit Alt I to flip me over to my design here. And let me find that. Yeah, that's a surface mount capacitor. So that's not what we want. We want to stick with through hole. So I'm going to delete this. And I'm going to go look for capacitors. Okay, so now we're getting into the right ballpark. Let me just go we're searching by price. That's fine. And then I can look at the footprints. A lot of these are pretty much the same. This 5.08. So a place. So I'm going to go ahead and pick that one. So here is my 470 nanofarad, and going back to the schematic, 0.47 microfarad, move the decimal 3 places, 470 nanofarad. Okay, that should be good. And that's what I need to connect to ground from VUSB. So I'll just get a ground up here. Alt W to wire it together. Okay, something like that. And I'm going to again hit save at this point. Okay, if I keep going back then, maybe I look at my notes and not that one, this one here. Something I had in my notes is coming in, maybe putting in a ferrite bead, a low impedance ferrite bead between wherever this power is coming in into my my power. Now that might not be so required, but I could come in here and just type ferrite bead. Let's see then. So if I went back to my notes, I had listed that maybe coming out of this pin, going into whatever my power coming in to the rest of this might be. So I've got this VDD down here. I'm going to go ahead and insert this. I'm just going to drag it up right here. Okay, so that would be some type of a ferrite bead, and I've picked one for now that maybe isn't exactly what I want. I'll have to research, are there better spec'd ones that I'd want to use there prior to ordering parts, but that's what I'm going to go with for now. Then maybe I want to grab these. Let's see, I've got PC3, so I have to go back to my notes. What did I want to do with PC3? And I had this sheet here, and this I know is hard to read, but if I grab PC3, I'm showing an LED, so I'd like to put an LED on that. Now, to do that, I probably don't want to drive that LED directly. Now, I think I could do two things. One, I could come in here and put in a resistor, and I'm guessing their resistors, are these also surface mount? Oh, and actually here they have axial. Okay, good. So much better. So let me go pick a 1/8 watt resistor. Okay, so they've got the through hole for the resistors. Why they don't have it for capacitors? Looks like they maybe do over here under. No, that's all surface mount. Okay, well, let me say that this, though, is our resistor, and I'm just going to say a 1K resistor for now. So what I could do is if I'm saying, well, this PC3 I want to connect to an LED, I could just directly go from that output to a resistor to an LED, and it looks like we got some through-hole LEDs. I don't think the color matters. These sizes are pretty standard. So I'll bring out an LED, and maybe I want this to come up here so it's out of the way a little bit. Okay, maybe I don't like that. Could I pull this up here? Maybe that's a little bit better. Okay, so then that's my PC3 going up to an LED. The other option is I might want to look for some type of a MOSFET. And again, I would have to search for some type of a through-hole MOSFET, or find out, can this down here actually drive an LED without causing potential problems? So I suppose I could go through the same process. Can I find a MOSFET that is in a package that is not surface mount? So then what I'm going to do is get rid of this line. And I'm going to put a resistor coming out here. So let me get maybe this a little bit closer. So this will be for my LED. And let's just say I put in roughly a 500 ohm resistor. Standard resistor values. And looks like a 511 maybe is a standard. Okay, so I'm going to go 511, and I'm just ballparking this, but I think that'll be good enough for now. And then when I get to this, I'm going to just delete this. I'm going to have to sort this out a little bit differently. So this signal coming out of this resistor is going to go up to that MOSFET. And up here, we want to maybe flip these around. Something like that. And then I'm going to want to have power coming into this LED up here. And I don't have labels on things yet. Let me come up here and just do a VCC, because this will be a 5 volt when we get there. And then I might also want to say that this is VCC right here. Like so. Now maybe other ways I could do that. I could put a label here. Oops. And it is going to be VCC. So I'm saying that this line will be my VCC line. I probably should put a label on this one coming in. This would be, oh, maybe I'd come over here and call this USB VCC underscore USB. And I don't like underscores actually, so I'll just call it VCC USB. And that's what I'm going to label this line right here as. I want this over a little bit more so it's away from that. And then this up here, I might put a label on it and call it VCC barrel. Okay, so I've got my barrel power coming into that, VCC USB power coming in. Jumper's going to let me pick one or other that's going to give me VCC. And then I might also want to put a label over here after it goes through this ferrite and call it something VCC filtered. Something like that. Okay, back up here then. Let's see, we've got my VCC, which I want on the outside of that filter, so that's good. So VCC coming into maybe a 511 ohm resistor to my LED into this MOSFET. I've got the signal. I've got something at least as a placeholder of 511 coming to that. And then coming down out of this should take me to ground if I've got that all right. So then I'll put a ground right here. And I'll just go like that. Okay, that is getting there, I think. Well, let's see, PA7, what did I want to do with that? So coming over here, I could look for PA7 in my list, and that is a clock out, which I'm also going to use as part of, again, this is probably hard to see. Maybe what I'll do is download this image and just open it in a separate window. I think I have a better way to view that. Okay, we'll try this. This will be better. So then, let's see, PA7654 these are SPI signals. So let me start getting those in place here. And I probably want to have an SPI header of some sort. And so I might come in and do a place and come into connectors, pin headers. 1x4, sorting by price. Let's find something they have in stock. Again, it really doesn't matter. A pin header is a pin header. But let's just say this is going to be our SPI header, and it's going to be using the signals around here. So I'll go like this for now, and maybe I'll just relabel that SPI. Maybe I'll even relabel these. And so I'm going to do PA4 is Mosey. So PA4. And again, I can go back in and edit this if I want to. Right click and edit. And PA4 Mosey. And then it's going to be PA5 is Miso. And then S clock and then select. So SCK. And then SS. Now there, I come in and do an SS. Question is, can I get the bar above it? Now I know some tools use a tilde. Here we go, perfect. So in the name, I just put a tilde SS, and that gave it the bar, just saying that it's an active low. So that I like to see in there. And I'm going to guess, and over here I see reset is the same, and pound is another way to do that, and exclamation up front is another way to do it. I don't know if it really matters which way. Like here, I could change this to go like that. So that's an active low reset. I think it's preference more than anything. This had started out with a pound, so I could maybe just do something similar over here. Okay, something like that. And then I will save that and get back out of that. Okay, so now we have these, and for now I will just run these. Oh, maybe I'll go like this. And I've got some more work to do with these, but this is how I'm going to do this for now. Okay, so that'll be my SPI connector up there. And let's save that. Other things, if I come back to my notes, and maybe I'll open my notes in this other image viewer in the same way. So I've got USB connector, barrel connector, power coming in. I have this. I made a note about having some type of a bulk capacitor. maybe at where power is coming in somewhere over here. So maybe I should add some bulk capacitor here. So maybe I'll just add an electrolytic. Now, these are again all SMD. Capacitors, electrolytic. This is a 5-volt system, so I probably want something that's 7 to 10 volt. Maybe I'll just do a 10 volt, see what I can find there. And maybe 100 microfarad. That would be plenty big for this board, I think. And obviously I'm not doing any fancy math here or anything like that. I'm just kind of picking, at least having a placeholder here. Price, this is in stock. There's lots of these in stock. Let's see, I'm going to pick this one. Lots in stock, and they have a part. So let me do a place. And I said I wanted that somewhere over here. So I'm going to go like this and then get a ground connected to that. Okay, and got that. Let me go back over here. Okay, internal voltage regulators in the chip. I want VDD to be 5 volts. I'm good there. Now, one thing that is often recommended is that maybe on these, instead of saying VCC, you might actually label it like 5V0. So that way I know that this is a 5 volt coming in, and this is all 5 volt here. So I could call that 5V0. I could probably call this 5V0 USB. I could do a 5V0 barrel. Again, just different ways to label those. But now I know this is my 5 volt coming in USB. This is my 5 volt. Oops, I labeled the wrong one. And that should have said DC barrel. And this is a 5V0 barrel. So just applying that label, and then eventually that'll get me to my 5V0, and then probably this one over here should be 5V0 filt. Now some people also like to indicate that it's a positive 5 volt versus negative. I don't ever do any negative volt work, so I'm just gonna not do that. So I'm gonna use 5V0 as my main 5 volt. After this filter, that would be what would come over here to these. And I think that should be fine. I think you could probably argue too, I should have 2 of these filters, one for each VDD. And if you want to break it out like that, I suppose you could do that. I'm not going to do that. Okay, so then coming back over here, let's see what other notes I have. Looks like I've got PA 3 and 2. Let's see what I was going to do with those. PA 3 and 2. So one of those to a switch and one of them to a button. So I said PA 2 to a switch. So I might come over here and see what can I find for a switch. So just pulling up the data sheet for this one and looking at that part a little bit more closely. I think that is perfectly fine for what I'm going to be using, so I will place that. Okay, and then I wanted that to be a switch that would go to PA2. So PA2, I want to go to that switch, and then I think if I've got this wired up right, I would take it to the center, and then maybe I'd run power on one side, ground on the other side. And I'm guessing that these over here, I would just run to ground to ground those, which let me do something like this then. So I will grab a power ground. I'm going to go like this. And the other thing I think I could do, and maybe actually that is what I'll do, is I'll just say these aren't connected to anything, not to ground, not necessary. And then maybe this one I'm going to pull up to my VCC or my 5 volts. So 5V0. And I'd go like that. Now, one concern I have, though, is if at some point I accidentally write out to these or try to do something, I maybe don't want this to accidentally connect directly to a 5 volt or to a ground without a resistor in place. So I think I'm going to put resistors in here just to be safe. And again, some of you are probably going to say I don't need them in certain spots. That's fine. But maybe I'll just put in resistors just to be safe. And we had resistors over here, and I'm just going to copy this one. I've already got a resistor, so let's go resistor there. So at least I've got some level of protection that if I was trying to, write out a positive here, but I had this for some reason switched to ground, I'm not going to just directly short it. Again, with me not knowing this board and what type of protections it has, this might be an easy way to do this. Okay, so, and I don't know if I even need this label. I think I'm going to get rid of this label. It's a switch. Okay, so there's my switch, and I'm either going to take a resistor to ground or a resistor to 5 volt. Now keep in mind, when it comes to actually building this, if you don't want these resistor values in there, just put a 0 ohm in there. That would be fine. Okay, so that's my PA2 going to a switch, and then I said PA3, I wanted like a momentary button. So I'm going to kind of do the same thing here with a momentary button. And I'll go search, and then, okay, this is a through hole. And let me hit place. They have some in stock. These are all pretty much the same. I have lots of these sitting around. And I'll come up here and really do the same type of thing here. Now, in this case, when I press the button, I probably want it to go low. Otherwise, have it pull up high. So let me do something like that. Oh, this shouldn't have been VCC over here. 5V0. Okay, so there's my pull up to 5 volt. And I'm going to make that a much larger pull up value. And maybe I'll do a 47K there. Okay, so this will normally have a pull-up, maybe a weak pull-up to 5 volt. This would be open. There's nowhere else for the circuit to connect to. But then if I press the button, I want that to basically go down to ground. And maybe what I can do is connect a ground over here then. And then, of course, if I do press that button and it's going that way, there's no resistor. So that's a problem. So I probably want some resistor in line here. And I'll maybe go with 100 ohm. Okay, so maybe something like that I could have in here. And that'd probably be similar to what I'm going to want for a reset. So this is just a signal that I can read in. And with this signal, that's normally going to be high. If the user presses the button, it should go that route and pull it low. And then this one down here, reset, I'm going to kind of copy this whole thing. And maybe just clean this up a little bit. So I'm going to take this over here and grab this reset line and essentially do the same type of thing. So that'll be the reset for the entire microcontroller. Again, it's pulled high unless I push a button, then it's going to pull it low. And I think typically on that reset line, I'm not going to ever try to read from it or write to it or anything. It's really, I'm only going to read from it. I'm not going to try to write to it. So I don't think I need that resistor there. So I could do something like this. Okay, so that's my reset. Should be good with that. Okay, so then let's see. Maybe next I'll take a look at these two signals. This is this crystal high frequency pins PA 0 and 1. And if I look at that, maybe I'll go back to this other view here, and that would be up here. So a crystal and the circuit that goes with that, and then maybe also running those pins out to maybe a pin header or maybe an actual serial connector. I suppose I could do both. So I might take a look at this other document then to see, did I capture anything on the crystal setup? And I did. So here I got my sloppy notes, and just basically going off of the high frequency, it's just the crystal and a couple of capacitors. And then when I get to the low frequency, it's the crystal, a couple capacitors, and an inline resistor. So pretty similar setups for those two. So maybe I'll just come over here and see if I can find a simple crystal to use. Again, a through-hole crystal. So, okay, I'm finally narrowing it down to something. I think that'll be in the right ballpark here. And this first one looks like there are plenty of those, and there'll be something comparable. But here is my 32K crystal, and that would be this one that's going to come down here. And from my notes, and this would be from the data sheet. Basically, you want to come in here and put in a placeholder for a crystal, and then a couple of capacitors, and those would be ceramic capacitors. So with that said, I'm just going to grab two capacitors, and I'll have to put in the values here that I'm going to end up using. But then we need an inline resistor for the one. Okay, so we're going to come out of, let's say K2. And then from that into a capacitor to ground. I'm going to come out a K1 capacitor to ground. And then before the capacitors, this crystal, so somewhere in there. So let me pull this down. Okay, something like that. And I might move this over here just to make it more readable. I'll have to get actual values here later for what I want these to be. I'm guessing if I go to the data sheet, it probably somewhere shows me what those recommended would be, or I would go back, see if I can find it in one of my tabs here, that reference design, and which I had up right over here. So in the reference design, I could go look at what did they do with the 32K. So there is their crystal. I'm just going to do a search for 32 dot right over here. And they put these cut points so that I suppose if you wanted to disconnect that crystal, you could do that. But they're using, in this case, we're coming off of K2 with a potential resistor here. They're putting in a 0 up front. I could do the same thing, K2. So they're starting out with a 0, and then in some cases they say it might be good to put a small value in there, but then we go to a 6.8 picofarad. And this other one is a 5.6, like so. That, of course, changes these manufacturer part numbers, so I probably should be careful and just clear those out because it's no longer that same part number. Then we have that. Okay, so that should be it. So K1, capacitor out. Okay, so that's one of the circuits. And then if I come over to this high speed, it'd be something similar. And maybe I'll just grab this much. And with the higher speed, I had in my notes no resistor, and they suggested avoid the 2 megahertz for the crystal frequency. And I'd probably have to go find out what was the maximum frequency. So an external clock running up to 32 megahertz. So I might want to come over here and put a note. I'll just use this little text and I'll say up to 32 megahertz. Adjust capacitor values based on frequency. And there's resources out there to look that up. I don't need this. Then I get something like that. So if I choose to populate those, I need to do some further calculations and make sure that whatever I'm choosing as my actual crystal, these values here are appropriate for the capacitors. So then I've got a ground I need to put in. And I'll put that right there. I should also make sure I don't forget, when I was over here, I said in addition to the crystal, I want to connect maybe a UART. And so 22 transmit, 23 receive. And I might see if I can find a serial. Can I find a DB9 serial connector? Okay, after a whole bunch of searching, I think I finally found one that I'm going to use. And that is my 9 pins, 10 and 11. Okay, so let's go put this out there. And this is going to be connected up to my high frequency. So I'm going to put this right over here. Then I need to go check DB9 serial pinout. And when I search for that, lots of information out there. I mean, obviously this is really old stuff, but 2, 3, and 5 are what I need to be working with. So ground is on 5, and then 2 and 3 are my receive and transmit. And so I'm going to just start out by saying I don't need all the others. 5 had to be ground. And then up here, I'm going to grab one line for transmit, one for receive. And I always seem to mess up those signals. So I'm just going to, for now, do the safest thing for me personally, which is I'm going to grab a 3-way jumper. And why does that say DC barrel? So this is a jumper 3-way. This is supposed to say DC barrel. And I'm going to bring this signal over here. And this signal over here. And then I'm going to take that out of here into maybe pin 3. And then I'm going to kind of repeat that and come down here and take this other signal right here and run that into... Oh, actually, I'll do it this way. I'll take this top one into here, and the next one into here, and then the middle one to there. Okay, so what am I doing there? I'm just simply setting it up so that this signal, which will either be receive or transmit, is going to pin 1 here, and it's also going to pin 1 here. This one is wrong as I talk through it. Then this one is going to come over to here. So basically, this signal is the same as that one. This one, pin 3, and I can clean this up a little bit. Will be like that. So 1, 1, 3, 3. One of them is coming from here, the HF2. The other one's from HF1, so PA1, PA0. And those would be, according to this, my transmit and receive. But what the jumper is going to give me the ability to do is I can swap it around. So if instead of me running this and it being transmit and me later realizing it should have been the receive line, I'm just going to put these jumpers that let me choose it, and or solder it in later and not even have jumpers if I know I have it right. Or I could take a little bit more time and just make sure I understand that, okay. And that's the other thing I could do is, okay, let's just go compare it. Does our reference schematic over here do anything with that? And they have a PA1 XF2 is their RX. And let's just go see, where do they have that running to? Debugger connection. Yeah, they're not going straight out to a serial type of connection. They're going to a different IC. And they got a note. Yeah, and they're putting in all of this just because it gets confusing. So I'm going to just leave my jumpers and call it good there. And then these probably need to go over to something that is, for now I'll put a ground, but it should probably be a chassis ground. And I'll come back to that later. Okay, so let me save that at that point. Going back to my notes, let's see. It does look like that PD7 could be used as an analog voltage ref, and so I might want to have a little header for that in case I want to do some type of analog voltage reference. So let's see, PD7 is down here, and maybe I'll put a little 2-pin header. So let me go do a place. Okay, so I'm going to use this as my analog reference, and so VREF A, I might just label this VREF A, and I need a coming out of this PD7 to whatever the positive is on this, so PD7 like that, and then the other goes to ground through a capacitor. And for now, I'm just going to grab this capacitor, and let's go look at that again. So through the capacitor from PD7 to ground. So from there to ground, and I might just do something like this. Okay, so I'll give a ground connection, I'll give a connection to PD7, and I'll put a capacitor in between. And for now, I'll put in a question mark. I need to validate what the actual capacitance of that should be. Okay, other things I got to note about differential pairs. I'll come back to that because that gets us into routing. Okay, good with all that. Decoupling caps, I'm going to have to add a bunch of decoupling caps. And the documentation suggests up to 3 capacitors per basically VDD pin. So I might just come in here and get those 3 set up. And they listed a 100 nanofarad, something between 1 and 10, and then a 1 microfarad. So I'll start out with the first 100 nanofarad, and then something between a 1 and 10, I'll just go 10 microfarad. And then they have a 1 microfarad, so like 1,000 nanofarad. So something like that. That's a lot of capacitors. But I now have those three that I'm going to want to hook up and place very closely to this VDD here, and then another one up here. And let's just see, spacing wise, or where do I want to place these is a question. But then I need to repeat that same thing for this over here. Okay, then continuing, I need to get to this UPDI, which is programming. And going off the data sheet, there were maybe a couple of ways of doing that. And I made note that it was on page 26, and I'll just flip over to that, which will be much better than my trying to read through my scribbles here. Okay, let me just get the data sheet opened up again. I can't find the right browser. Okay, so then I said page 26, and I think that was according to the page numbers on here. Yeah, so then here's one style, and then up here is another style. So it's a 2x3 or a 1x4, and they kind of have a V1 and a V2. So what I was thinking is maybe I would just set up both. So VDD ground, I've already got that set up. The reset line I would need to pull in to this one down here. Up here I don't need it. All I need is this this UPDI going to that. So that, let me start with the version 2 connector, because I think that's probably what I'll use. I'll put that in first. So I need a 1x4 pin header. And I already had a 1x4 up here, so I'm just going to copy and paste that. And let's see, UPDI, I don't have a good place to put this, so let's just run this. Maybe I'll just set this up here. Now, I don't have to have all these connected directly like I'm doing down here. I could also just put this up here, and maybe I would put in a label that just says programmer. And maybe I would say V2, since this is the V2 programmer header. And if I look at that, pin 1 needs to be my reset signal. So this is my reset signal here. I could just put a label out here and call this reset pound. I could grab that little label and bring it up here, flip it around, and maybe just pull this out. And so now I have my reset signal connected there. Followed by that, I need my VDD, and then I need my ground. Well, VDD, remember I'm using this 5V0 filt. So I can put that up here. And then I need ground. And then the last one I need is my UPDI signal. So I might come over to UPDI and just actually put on this and call it UPDI, like so. And then come up here and put that in there. Okay, so maybe I'll size these like so. Okay, so then I should probably relabel this, and I'll call this prog V2. And then I need this connector, and maybe I'll pause for a second. And when I was over here, I put these labels, these network labels over from here onto those two signals. I should probably do the same for all of these, because then later when I do routing, that will be helpful. So I'm going to just run through and do that real quick while I'm here. So this would be my Oh, let's just get these all put in. Okay, so with all that labeled, I think I've got all of those. I have my prog V2. Okay, back to this then. Oh, maybe I'll take this and make it a little bit larger. And I'm going to make a copy of that and have the programmer V1. I'm going to put both headers in because I don't know what I'm going to use for an actual programmer, because I don't think I have programmers for this. So it's possible I might have to purchase one. Now, in this case, let me just double check I've got that first circuit. Reset, VDD ground, UPDI. I've already got those caps over here, which would already be connected up there. Okay, so I have all that. Now let's go back to the older V1 connector. And that's a 2x3. So I'm going to come back in here and change this to a 2x3 pin header that I'm looking for. And that looks fine. So I'll put that in here. And they're showing the UPDI goes to pin 1. So I'm just copying and pasting that. And then I have no connection, and on the other side, middle, no connection. And then I've got ground and VDD. Okay, so now sometimes what I'll do is I'll come in here and I'll put in, blocks or call this out. And maybe in this case, I would put a block like that. And I might divide this and say, okay, there's my programmer 1, programmer 2 up in that block. And maybe I could, put these somewhere that is a little bit more out of the way. So I could come down here and say, okay, there's my programmer. You could do the same for all these. You can choose, do you want to connect it like they are up here, or do you want to put things out in separate blocks, just match up the net labels, whatever your style of connecting you find easier. Like some of this is getting a little bit messy. It might be better if I would put this serial connection, for example, and these off into a separate block, but this works. And you can also decide, do you want to go onto separate sheets? Also, I'm keeping this all on one sheet just because for this project, I think that is fine. Okay, I'm going to keep on going here then. So I got that. Decoupling caps, I'm good there. Reset, let's go see if I'm good on the reset signal. I think we already had that in there. So I've got a pull up. Yeah, now they're showing in their design a resistor going into the switch. So that would be here. And then a switch that then goes to ground. And then parallel to that is a capacitor. So I do not have the capacitor parallel to this. So I should probably do that. So let me go grab a capacitor. And they're showing that capacitor is between reset and ground, really. And so I might just go like this, grab the label. Well, let's see. I'll just come up here, reset pound. So put up here. Oh, I don't like this turned like that. So can I just go like this? Reset pound. And okay, so I've got my reset pound there. And then ground, so capacitor to ground. Okay, so that is covering this. So my reset, they're showing again through a resistor to the switch. So I've got a pull up. The pull up is optional because there's an internal pull up, but the reading I was doing is saying you may want an external pull up in some scenarios. So I'm going to put it there. If it's not needed, just simply don't populate it. That's easy. And it might be too that I could even say, well, you don't need to populate this. So I'll do a DNP 7K or 47K. That just tells me that I don't need to populate it, but if I am, probably put in a 47K resistor. And the thing I'm missing here is then that resistor. Okay, so then I need to grab and put this resistor in here. And this really isn't doing me any good. I'll just call this, button 1. And this is not a do not populate. There's some value there that I'll have to figure out. R1, I had written down 330. And the capacitor 100 nanofarad. And that's stuff I pulled out of the data sheet as I was reading through it. Okay, and it could be that people would argue you don't need this one, but I suppose if I push the reset and it takes it to ground, it maybe is good to have some resistance there. And maybe that's why they're putting that in there. I know some other boards that's not necessary. Okay, and then I've got my capacitor that goes from reset to ground. Okay, so I think I'm good on all of that. We've got this put in there. Their documentation is all in mils, which I find annoying. And so 100 mil like spacing on their pin headers, and that's a 2.54 millimeter. Got the crystals. Then I have some other to-dos over here. So let's just see. So do I want to put test points in? Do I want to put a socket for the chip itself? I'll worry about that later. I don't think I'm going to bother with that. Do I want to put some accessory power connectors? So maybe some pin headers just for power to connect to other things. Okay, so I'm just building 2 sets of 4-pin headers. One that'll give me a 5-volt, one that'll give me a ground. I'm also going to maybe put on some 2-pin headers that are just ground. And I'm going to paste 2 sets of those. And these are just simply going to be ground headers. Oops, ground GND. And I'm going to label all of these the same. And put a ground through all of that. So I've got 2 pairs that are just ground only, and I'll use that for my oscilloscope so I can clip onto those for grounding, and I'll just do that on 2 opposite corners of the board. And I could, again, put a little box around that and put a label in there. And I'm just doing a lot of copying and pasting here, but I might just call this power headers. Let's see. So that, I'm not going to do any test points right now. Okay, scope grounds I just did. I'm not going to do a socket. If I was going to do a socket, I might also look for like a ZIF type of 3D socket component to put on here. I'm not going to bother with that right now. Accessory power, I got that. Inline resistors, there are some times where I've run into it is good to have inline resistors on these lines here. So I think I'm going to go ahead and put those in. And worst case, I just put in 0 ohm resistors. But at least I've got them here. So maybe I'll put these as 10s for now. Okay, so this is my SPI. I've got my clock, and you typically want very close to that clock, this resistor, a low value resistor, maybe 10, 20, 30, somewhere in there. And then MISO and MOSI, I guess I read different things. It seems like you don't need them, but I think even as I was looking at one of the documents, let's see if I can find that. Back here, it was probably the hardware design considerations, and it had something on SPI, yeah, right here. And they're putting resistors. So before you go out to an SPI bus, that you might want to have inline resistors there. So not on the reset, but clock, Mosey, and MISO. And so that I'll put those in. And worst case scenario, I just put in, and maybe I just even put that here for now. I just say, well, put them in as 0 ohm resistors, but then at least they're there so that if I want to come in and put values in there like a 10 or 20, I can do that. I don't think I need to do that over here with the select line. Okay, that's my inline resistors. Okay, I got a switch, LED button, got all that. SPI header, I've got that. USB connection, I did go with the USB-C through hole. Oh, port D, I've not done that. I've not done standoffs yet. So I might want to add some type of a standoff. And let's just see if there are any standoffs. I've actually made my own standoffs because I didn't really like the standoffs that I was finding in the tool. Let me just use one of the standoffs that I've previously created. I can go down to my library and go to my personal, and let's see where I've got it at. Not that. All. So I made some different standoffs, and I'll just show you what they are. And making these is quite easy, and I can choose what size standoff I want. I'm going to go with these smaller standoffs. And if I just double click that, I can go place 4 of these. Now, if I want, I can just edit one of these so you can kind of see what it looks like. But basically, you can just go up and say that you want to make a new component, and it brings you into this type of a tool. And I just drew a circle, and then I created or inserted a pin so you can place a pin. And I just did a single pin on it, so it's a single pin connector. But then from there, you can also create then a footprint. And I have a different video, if you look at my videos, on creating a custom component in EasyEDA Pro. So if any of you are interested in this, go watch that. But I could come down into my library footprints, and I could edit that footprint if I wanted also. But you would create a footprint, and let me do an edit footprint. But then you would do the same thing. You would actually come up here and you would place a pad, whatever it might be. And in this case, you can see I've created a 3mm diameter pad that's multi-layer, meaning it's a through hole. And then after that, you can also, well, I think that's about it for that specific connector. So I've got the device, and the device is this standoff. And I had created that with just simply looking like that, and then I created the specific footprint I wanted to use. And then if you wanted to have a 3D model, you could associate a 3D model with it. Now in this case, it's just a hole in the board, so there's no 3D model that needs to go with it. But I created those, and they're just in my personal library, so I can use them, reuse them whenever I want. But like I said, if you're interested in making your own devices with their own custom footprints, leveraging 3D models, I have a separate video on my YouTube channel. Okay, so that gets me to a port D connector. So here I have PD 0 through 7. So I have 8 bits that I want to connect to probably a 1x8 pin header. So let me go grab a 1x8 pin header. Okay, that looks good. Let me place this out here. And let's see, I'll maybe just put this right down here and rename this to just be called header. Now in this case, I want to connect, these 8 signals over here. I might do that with a bus. So I can create a bus, and what I'll do is just come in here and tell it that I would like to create a bus. And I'll see if I can find enough space here to place this. Let me start. Oh, I might actually slide this 511 over and just give myself a little extra space. So I'm going to draw a bus that goes like this. And maybe I'll just come down and drop it like that. So then I can come over here and just connect these up. And you see it says bus 0. Well, if I come up to the bus, I can give it a label, and I might just call it PD. And I want to go from PD 0 to 7 like so. And now you notice it even renamed that automatically. So now I can come in here and just put all of the rest of these in. And all I'm doing is drawing wires, and it's automatically connecting them to the bus, and it's grabbing the next signal name in that. And I'm going to manually pull these left a little bit. So I'm control selecting. Okay, so now I have a bus connected up on that side. And now I want to do the same thing again. So when I start drawing, it's going to start, being that I finished the last one at PD7, it's going to start again at PD0. So I'm just connecting in all of these and saying these 8 are all part of a bus. And that way I can now connect them in here. Okay, now this one it doesn't like because I had this other thing called, and I named it VREF. So it says, well, merge, please choose one. I'm gonna, okay, let's choose PD7, confirm. Okay, so it's going to use PD7 for that. So this PD7, I lost the label, the net label of the analog VREF, which is fine. So this will say now PD7. So when I go to route it, this wire will say PD7, not VREF A or whatever I had on it before. Okay, so then let me save and see, am I missing anything? I might real quick jump over to this sheet again, and did I get all of this connected? So I have my high-speed crystal, I've got the connection. Oh, one thing I was going to do on the serial is I was also going to give it just a plain old pin header. So let me grab let's just do a 3-pin pin header. Okay, so then jumping back over here, these are connected. This is connected. We have this header in place, LED, that. Okay, I think all of that is hooked up. Let me check my other notes one more time. Okay, so I think with that, then this is close enough. And I could spend a lot more time on this, I'm sure, making it look better, laying it out, maybe breaking some of the stuff out into sections like this to make it more readable. But I think this is probably sufficient. And what I'm going to do now then is update that schematic. And we'll see that there's a bunch of stuff that I'm going to have to get laid out. So this is what we have so far. And before I even draw the board itself, maybe we'll just start putting everything, around this chip here. And so this is my main MCU. This looks like it's the DC power, and power on this chip is going to come in, looks like right here. That would be my ground, and then this would be my 5-volt, those 2 pins. So maybe for now I'll just place this over to the left. We have the USB-C connector, which I'm going to put all my connectors on the same side, and I'm going to put this down here since these signals are going on this side of the chip. Oh, what do we have here? This would be my ground and VUSB, and so that looks like that is a capacitor, is what that footprint probably is. And I can come over to the right and see that, yeah, it's a through-hole capacitor. Okay, great. And that's to go from VUSB to ground, so why don't I put that as close to VUSB as possible, something like that maybe to start. This looks like, okay, that's my power selection. Which source am I going to use for power? And so in this case, I can pull in power from that pin to here, or this pin. So this could probably just go right over like this. That's my power selector. This would be a resistor. Now, what's it going to? That's where I can see it's going from 5-volt, but it's going down. And see here, I don't have a real good name on it. And that's because if I go back to the schematic, if I just pick this resistor, so I select it and then go back to the schematic, it should automatically highlight it, and that's what it did. And so in this case, it's my resistor going to my LED to 5 volt. Again, if I had a net name on this right here, that might have indicated something more helpful over here. That is the LED that I can work with from this PC3, so I can choose where I want to place that. This is my transistor, and I should be able to go from that signal at this resistor here. So I'm going to put this resistor, and then I have a transistor, and then I'll have a ground, and then this will go into my LED, and then a resistor. Then over here, let's see, this looks like I'm going from 5 volt to 5 volt filtered, so that must be an inductor. Now this is showing my switch. So where might I want to place that switch? This is a pin header again. You can see SS0 or SS pound, but then I don't see good signal names here. I might want to fix that. So I'm going to jump over to my schematic, and that's these labels after those resistors. So SCK, I might want to come in here if I want to make that more readable, and I could label these here. And let me just see if I can slide this over. But as I do that now and I go back and update my PCB, what you'll find is that it is much more helpful on that header wherever we might be working on that. But now I can see, let me get back to that header. Where is my header? Right here. Now it says SS pound and then SEKR, so I know that this is my SPI header. And if I look at those signals, they're going to the resistors, and those resistors are right up here. So I got one there, and then this corner one. So in that corner one, I don't have a resistor, so maybe I'll go like this. And I'm going to try to do my best to keep, all of these traces short. Switch isn't so critical, so I'm going to pull that up and out of the way. Let me get these other resistors brought up. And I'm just pulling with my mouse. I'm left clicking, dragging, and then as I get it where I want it, kind of hitting the space bar to flip it into place. And then dragging from there. And trying to get these all lined up like so. And now I might just bring this up like this. And this SS will go a little bit longer. That's probably fine. And maybe something like that is where I will place that. And then I can decide, what do I want to do with this switch? Is it fine up here like it is, or do I want to bring it down and try to compress this a little bit? I'll leave it like that for now. Then let's see. Looks like I've got my serial connector. And again, I probably want to try to keep all my connectors on one side. And this is going to connect down to, see here again, we've got these just weird numbers, 1 and 3. Well, it might make more sense if I come over here and label that. So one of these, though, I know is ground, and then I've got the 2 signals. And it probably doesn't matter really which way. And it could be this is a pretty big connector that I might rotate it for board space, but we'll come back to that and just see what this starts to look like. Oh, what else do we have over here? We've got another, looks like this is a couple of those signals and a ground. So this is just simply my, instead of the serial connector, I can use this header if I choose to do so. So I'll go like that. And then I've got all of these. These are just power and ground headers. So those will go on the edges of the board wherever I end up doing something with that. So there's a power, there's a ground, power, ground. And I might just put a set of those up top and a set down wherever my bottom's going to be. And then I'll put real quick oscilloscope ground down here and another oscilloscope ground up here. Got my four corners I need to get with these, these standoffs. And I'm just kind of throwing them in the general area for now because I've got to actually size the board here and figure out what that's going to look like. It looks like I've got some resistors to go with my, this might be reset, or no, in this case it's button. And again, that's where that net label comes in handy. And here we've got a capacitor. So let's just look at these signals and see. Capacitor ground. And this is C1, so let's go look and see what was C1. C1 right here. So that was a bulk capacitor. So I want that close to where my power is coming in, and I've selected. So that might be right about here. Okay, then back to my switch. I've got button 1, which is going right up there. So this stuff all kind of needs to go up there. So I've got a switch I can flip back and forth, and then I'll have a button that I can do something with. Oh, this would be my header for this port down here, and so those all line up nicely. I'll just give myself some space and bring that down here. Oh, this would be a programming header. I'm sure this is the other programming header. Yep, so there's two of my programming headers. And if I come up, that main signal that it uses is right here. So it seems like having this off to the right might be good. Reset is there. PDI. Okay, so I'm just going to go like this for now. And the 1x4 was the newer style, and then this was the older style. So maybe I'll just go like this and say, okay, I can plug into either of those. Want to try to leave a bunch of room around it. So maybe I'll go like this. So I have both styles of connectors there. This switch looks like it's reset switch. So reset, 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 reset. This all looks like it's reset focused. So let's come up here, and my reset signal, let's just trace that back here. Okay, here's reset, and that's going there, but it also, here I have this header, so maybe I will just bring this down here. There's reset. And then my reset switch, which I'll put down in the lower corner. And let's see, where is this going? That's going right there. That would work fine. And then that'll get over to ground. And this is a capacitor for reset down to ground. So I'll have to see, where do I want to put that in? And I'll probably put that close to the switch, I think is the goal of that. Actually, maybe I'll put that close to up here. Okay, one other thing I ought to put in here before I forget is when I look at this VGA connector, it has these grounds here, and actually these I might not have any choice on because it looks like maybe the symbol has them tied together, this ground and this ground. So that's going to go to the ground of the board. if I look at this USB, it looks like it also has a ground. Well, and actually I should go back to the schematic. So on this, it's because I had this over here. So I'm going to actually delete these connections and try to build more of a chassis type of ground. And typically, I guess the way I've seen this done is between these chassis type connectors. So maybe the outer shell of this serial connector is to put in like a 250 volt 1 nanofarad capacitor, and maybe in parallel to that a 1 mega ohm type of resistor. And maybe then I'll go grab, let's see here, just on my common, I'll grab a radial, and I'm going to grab something bigger than 1/8. I might put in something resistor wise to go maybe up to a mega ohm. So maybe I'll go 1/4 watt and bring that out. And I might just set this as a do not populate 1 meg. So it's there optionally if I decide I want to use it at some point. And then I should probably go find a capacitor that is 1 nanofarad, 250 volt type of capacitor. And I don't know what's out there for through holes for that. So let me just add a component and see if I can find something. So 250 volt capacitor, 1 nanofarad. So let me just grab this one. It looks like that is stocked, and I think that will be something I can use. So there's my 1 nanofarad. So here are these 2 lines coming off of this that go to the shell. And then I will connect that up like so. And I was thinking I had the same thing over here. So this is on the USB. I'm going to go ahead and just put in a connection here, and I will just put a net label in that connects it to that other one. So I will just call this chassis ground. That's actually what I meant. If I said earth ground earlier, I meant chassis ground. So put that there, and then I'm going to put the same thing right over here. Meaning that when I get to my PCB, this shield, I will connect to this shield or through this, like so. And that way I'll just purchase one of those capacitors. Okay, did I have any others that had that type of shield? Let me save this and go into I'll hit Alt-I to update this again. Okay. And so then the VGA, I've got my chassis ground now. I've got this USB connector, so let me go double check that. Did it have... that'd be this one here. And yeah, it's got the chassis ground, regular ground, my data lines, and then a 5 volt USB. Okay, so I think we're good there. Well, let's see, what do we have left down here? So I have chassis ground. So this is probably the stuff I just added. So let me bring this up and set it over here for the moment. Definitely a big resistor potentially there, but I suppose that's okay. And I might pay attention. I want to try to give these nice clean runs up here and keep stuff out of the way. But I have the chassis ground, and that's my capacitor. And the resistor is the one that will be the optional do not populate. So I think I will come down here like this, and that will be okay. and then my resistor. And then I might pull this up a little bit more. Okay, let's see what's left down here. So this is PD7. Let me go look at what were we doing there. PD7. So 1 is to this VREF. So U11 is just this VREF, and there's a capacitor in parallel with that, which is 12. So that's what this is here. So that is my VREF. And that's going to be on this corner of the board. So I'll just drop this over here. And maybe while I'm up here, I'll come in and put up some text and just type in, this is my AVREF, and drop that there. Make sure that that is what VREF A, I guess is what I called it over here. So I can do that. VREF A. Now I noticed that, it's a different color. And if I go look at this, it says it's on the top layer. I just want this to be a silkscreen text. So I'll say VREF A like that. And I can choose, what size do I want this to be? Height. Now this is all shown in mils, which again, I don't like. So I'm going to see if I can change that setting. And I think that would be in properties of just the clicking out in the space in general. And snap size, mils. Okay, so here I can come up and change units to millimeters. And now when I go back to this, I get a height in millimeters. So let's go 0.2. That might be pretty big, but this would be my VREF. And I'll copy and paste that. Where did it go? I thought I copied and pasted. Let me try again. This I'm going to shrink down even further. Let's go 1 mil. And I'm going to thin it out 0.15. And then I'll do a positive and a negative. And maybe bring that together by 1 more. Okay, so then I positive, negative, and a VREF label so I don't forget what that is. And these designators I really don't need, so I'm going to just choose this U11 and get rid of it. So again, this here is a capacitor, U12, and if I come over here, that's a size I've got to figure out yet on the VREF. What size capacitor did they put into that? Got that in there. Let's see, this is my 2 different oscillators or crystals, along with one had the resistor and then a couple of capacitors that go with it. And looking at this, where you need to get up to that pin, and this you want to be as close as possible. So I might pull that out. And this looks like intended to be soldered in and laid over. So we got a pin there. So I might want to move some of the stuff that's up just above it here. And we'll come to that shortly. And maybe I'll just do that. I'll go like this and that for now. So I want to try to get this down here as tight as possible. And, this inline resistor probably isn't helping me a whole lot. Maybe what I can do is bring some of this down. Like so. I could maybe bring this over here. Like so. And then it's like, okay, I've got to come through here. How far out do I want this to be? And then ideally around that, I will put in a ground fill. And I could probably, no, I think I'm going to leave it like this. And maybe what I'll do is rotate this like this. Okay. Something like that I think is workable. Now I want to try to put copper around all of that. So I can come up here and there's a couple of different shapes I can work with. There's a fill region, a copper area, board outline. So I want to do, let's just do this one here. This is a copper area. And I'm just going to set it to a rectangle for now. And go something like this. And I want it on the top layer, and I want it to be a ground. So I'll confirm that. And then maybe I will just take it out like this. Okay, so that's just a top layer copper fill. Good enough for now. And let's see, top layer, pour, ground. Okay, fill style solid, rebuild it. Okay, so there's my top layer ground copper. And we'll see when I get done what that looks like, but that's what I'm doing for now, at least on that. And I don't have any routing done. So this is going to look different when it's done, of course. Let's see, coming back down, it looks like I have these others, a couple of capacitors, U16. Let me go double check what that was for. Okay, so 16, 17, 18, and 13, 14, 15. So 13 through 18 are just decoupling caps. So these are all decoupling capacitors that just need to go as close as possible to those pins. So here I've got my 5-volt filtered, and then I'll have my ground right there. And I want to make sure I get the most important one that they list, which is the 100 nanofarad closest. And the one I have selected is the 100 nanofarad. So I could go something and just put these all on the end if I want. Okay, and I could even just extend this copper fill, but I'll come back to that later. So that'd be one, and then if that was one of my powers, the other is right here. So I'm going to need 3 capacitors close to this space. Probably right here would be ideal. And I've got this inductor, so I might want to try to slide it over. And let me go get these. 13 is the one I want closest. And go like this. And then this is going to have to connect 5-volt filtered, so I'm going to have to get that over to here. And you typically want to go through the caps anyways, so I could go something like this. And then I just need to make sure I get a good 5-volt to that, which I will worry about routing that after a little bit. Or I come up here and I have a button and some resistors. Those are probably not so critical. And that's going over there anyway, so maybe I'll just slide this stuff over. Okay, so this is reset circuit. I could probably just drop this right here. Okay. So now R4 and 5, let me go back and see what those were for. Those are around my switch. And you can choose, how packed do you want this to be? but I'm going to go ahead and put that right there and this right here. And I'm just going to have to make sure that I can get to 5 volt. And it seems like generally I have my 5 volt stuff maybe up higher, but we'll worry about that when we have to route this, if we have any problems or not. And this would be my high speed probably. And looks like that's going to be right up here, which is, I want it close to all of that. So if I do end up running this, so this stuff's going to have to move. Those straight out. You know, this is just a switch. Probably one of the things that I'm least worried about, you know, as far as high speed or anything like that. So let me just take these and pull them up out of the way for a bit. And this stuff here, I probably could slide over a bit. And maybe some of that stuff will come back here in a little bit. But let me go get... Okay, there's my receive and transmit. And then one of these for each side. So probably like that. And like that. So those would be my capacitors. Okay, probably something like that. And delete all those labels. Okay, this is gonna, this here goes there, this here goes there. That's probably fine. And then I can try to pull some of this stuff back in. Ground. My switch, which is going down there. So that's maybe not a real great spot to try to run it through there. You're not going to want to have signals going underneath one of these crystals if you can help it. So if that's the case, I might just bring this over here. And this is a ground. And that's a 5 volts. Oh, maybe something like that. And is that it? Maybe that's everything. So then can I compress this footprint a bit? You know, this is analog reference. I could probably pull this up here without any problems. And maybe I pull this in like so. And maybe try to straighten this out. So then if I come up here, let's see, what can I pull in? This was just ground. This was just a ground header. So all of this stuff, I can be quite flexible with where I place it. And so maybe I will get this lined up first. Let's just say we pick a spot like that for now. I can see this side's going to be a problem. But maybe what I'll do is wrap this serial connection around. And so I'll pull that out of the way for the moment. Go like this. And let's just say that's going to be maybe an edge of a board. Now I can pick both of these, so control click these two and then come in and align my tops. And I can kind of do the same thing with this one over here and this one. I can align the right side. Okay, that's good. And then this one I'll eventually want to get into probably right about here is where it needs to be. So I need to get all the stuff compressed into that space. And I'm just going to bring this up. It'll be my power connector. Should be fine. Okay, so right there, that's getting close to showing what this board might look like. But it seems like I still should be able to compress this a bunch more. This seems to have a lot of empty space here, not for a very good reason. So maybe... Okay, that's maybe getting close. Let me save that. And now probably actually draw in the board. So I can come up here and there's a board outline. And I'm just going to do a rectangle. And let's start right up here. And then come down to something like this. I can then right click on that and I can create corners. So let's do an add, and let's do a 3 millimeter. Okay, that is the angled corner, which is not what I want. So let me try that again. I'm going to do an add, and instead of this chamfer, I'm going to do is it a fillet? I'm assuming that is how that's pronounced. Okay, something like that. That doesn't look too bad. Let me just see what this might start to look like in a 3D perspective. Okay, and so now you kind of want to look and see, do you have spots that physically you're going to have problems? Well, here's one problem. That connector is backwards, so good luck plugging in power. Serial looks reasonable. Might want to shift it out just a little bit. Let me do those changes here. So serial, now that I got my board outline, I can probably just take this up and put it right there. That's probably pretty good. This was wrong, so I'm going to need to rotate it around and something like this. And so I've got ground. I've got this coming in here. And then from that, I would want to have my power options. Did I have my USB backwards too? Probably. So let me go back to save and 3D. Okay, so now this 3D connector I used that doesn't have the model. And so that could be a problem because I'm not seeing a good visualization. Is that connector backwards? And it likely is backwards. I probably need to spin this. But it might be nice to have a 3D model for this. And so if I go edit that device, I can look and see if there's a 3D model, and there's not a 3D model connected to it. So I guess some of the choices, I could either find a different USB-C connector that maybe has a model. And so let's go USB-C. And they're labeling it plug-in for through-hole, I believe. Yeah, and I had picked that one. I don't know what this one is. And maybe there's some others down here. No pictures of them and no stock. So I think I may be just stuck in not having a good model. But I could probably go see if there is a model for this one out there anywhere. Or I could just say I'm not so worried about the model. I just want to make sure I get the pin out correct. And I need to interpret this. Okay, so so let me understand the picture here. Okay, that's why it's a stand-up. I was thinking it was a right angle, which it's not. It's a stand-up, and I don't know if I really want a stand-up connector on that, so I don't like that idea, actually. So I need to come back and find a different connector. So this connector is one that stands up vertically off the board, and that just isn't what I would want. So let's go see if we can find any other through-hole USB-C. Okay, so I'm going to take a look and see what this one looks like just real quick. Gonna update the board and temporarily just going to plop it right there. And just see, does it? Okay, good. It's got that, and it is through hole. Okay, well, that one might work out well, so I'm going to go with that one for now. So this one I need to get rid of. U3. Delete. Now this one has more stuff to it. And I think all I need to worry about is picking one of these data lines. And I think I've seen people either just jump across so there's two data pairs here, I believe. So data pair 1, data pair 2, but there's a positive, negative. I believe this is differential pairs. So two differential pairs, positive and negative. And then I believe what the right approach here is when I get to this DP to connect it to both of these here. So I'm going to put in a net flag and this one here and cancel that. Oh, I already have a flag over here. So I've got my DM, which is right there. So let me copy that. That would be the negative, so right here and right here. And let me go grab my positive and put that in right here and right there. Okay. So that's basically connecting DP1 to DP2, DN1 to DN2. And I think if you don't do that, then if you flip the connector, you're only going to get it to connect data lines if it's one way or the other. So if you have it working and you flip it 180 degrees and plug it back in, it won't connect the data lines. It'll connect power because that is on both of these, but not the data. So that, I think, is how that needs to be connected up. And I really don't need these at this point. So let me just get rid of those. Okay, let me go back and update and get this placed. Okay, I'm going to get rid of some of these little labels and let me just do some quick silk screen, updates to label stuff here. Okay, let's see what that looks like. Okay, so I got my serial connection, DC power, USB-C. Now, one thing I don't have is maybe a power indicator. That would be maybe something else that would also be good to have. So maybe I'll come over to my design and I will grab just this much. And this will just be my plain old just power indicator. Okay, so I'm going to take 5 volt, which would be coming out of that jumper. So I'm coming in USB or I'm coming in barrel. And then from there coming out is this 5 volt. So as long as power is going into my ferrite bead here, this should light up. Okay, so now I have this for power indicator, and I think putting it right up here would be fine. And the resistor that goes with that. Okay, so I have a power LED. I have this LED over here that I can turn on based on whatever I do in the board as far as programming output. I do see I don't have a fill-in around this. I might do that real quick before I forget. And then maybe we're getting close to doing some routing. And so I'm going to just copy and paste this. And I'll show you later, I'm going to fill the whole top with ground anyways. So some of this might be completely unnecessary, but... Oh, serial power, USB. I got a ground, a double ground down here I can clip on with an alligator clip for my oscilloscope. Same thing up here. I have the 2 programming headers, whether I'm doing the old style or the new style. I have a port I can plug into for those 8 signals. Bulk capacitor that goes here. These 2 power connectors, I have the 3 capacitors. I have the capacitors around the crystals. I've got my inlines for my SPI, which I should probably label that SPI. So I think with that, I'm going to move on to routing. Now, a couple of things. Oh, maybe one thing that I will end up doing is putting a copper fill on the bottom and top. And ideally, when I'm doing the routing, I'm going to do all the routing on top or try to do as much of it as possible on top. Now, to do the routing, I can do an Alt-W and just come in here and start clicking and connecting between. If I want, I can also do a Shift-W while I'm drawing it, and I can choose what size of a track I want or trace. And I'm just going to basically go through and start doing that here, and going to start out with my most critical things first. One of the things that I will have to do, let me just say I start out over here with these, the different crystals. So I'm going to come in here and I can connect here to here, and I see I got plenty of room to make this wider. So I'll do a Shift W, and if I go up to 1.27, that fits perfectly fine. I could do the same thing here then and go to a 1.27. And that now is too much for this. And so I'm going to take that down, 0.05. Yeah, that's probably fine. And I'll just keep using that as I go here. Okay, and you can click and drag these around, and I can do that like so. And maybe I'll even come back to this and just for consistency, make it the same size. Now, one of the things I often do is I don't even bother running the ground lines. And here's what I'm going to do. I'm going to come in and let me do copper area. Bottom layer tied to the ground net. I'll confirm that. Okay, so now I can come in and do a rebuild. And I usually turn off this optimization. I find that when I'm trying to do tight spaces especially, it doesn't do a good job of filling. So I'm going to set optimization to no, rebuild copper. But now what you'll notice is anywhere I have my grounds, let me go find one here. It's already tied into ground through that bottom layer. And you'll actually see it looks a little bit different because this is being tied into that bottom layer ground. Now, while I'm working, if I don't want to see that bottom layer, I can come in here and just say, don't show me the bottom layer at all. Or there are filters, and I can come into the filters and say, well, I don't want to see fill regions. And I can turn off fill regions. I can turn off copper regions. But so in this case, I could just toggle off my copper regions, which maybe I'll do for now just to make things more visible. Okay, let me keep going with this. So the size I'm picking for this is probably, well, it is overkill, but that's fine. Okay, this, I want to be able to run this right through here, but it seems like it's a little tight. So then I have to figure out how I want to route this differently, or just simply drop down this trace. And if I go to 0.254, that's plenty small for what I'm doing. So maybe I'll just do that for all of these. Is 254. So I'm just looking for how to maybe optimize this. So I'm going to undo that, the last two here. And, if I come in and bring these across, I need to get over to that. And right now I have that switch in my way, the switch line, which is probably less critical. So I'm going to delete that. Let me get this run over here. Okay, I need to get around. So I might go this way instead for that. Now keep in mind, if I'm going to use the serial connection, I'm not going to place this crystal here. So that'll be a non-issue. So I'm either going to run the crystal and not connect the serial, or I'm going to run the serial and not connect this crystal. And so that doesn't concern me that I've got this, coming off of there, coming underneath that crystal like that. I think that'll be fine. And now I need to get these up here. Okay, so I can decide how I want to try to make this prettier, but it's there. I was trying to drag a track and I grabbed text instead. So I can come over to my filter and I can filter out text. So I don't want to see it, and I'll take away the check mark that just says, even if I could see it, for example, here I can see it without the check mark there. I can't do anything with it. Okay, so let me move this stuff a little bit, or the best I can. And serial is such slow speed that I don't think that, some of these being longer is going to be a concern. But now I've got to get from here up to there. And I can again do something like this. And I don't know if I really like that. So maybe I'll bring that up. The other option, maybe if I look at this, is if I just delete that, I'll run it up on the other side of this other track. And I'm going to come back and fix this, pull this in. That might be decent. Now I can come in if I was worried about length. This is 3809. This is 49. So this is 10 longer. So I could see if I'd want to do something about that. Of course I can shrink these in. It is nice to have some space there. And 48.7. So I might want to lengthen this one a little bit. And there is an option. Oh, let's see if I can find it. Route and equal length tuning. Okay, so that's 47. That's close enough. And I can see in this case, this one is quite a bit shorter. And this one here is 50. This one here is 34. So again, I can do a Shift A and then, just play with where I might come in here and lengthen this. Oh, that was 50 right there. Okay, so I have a 50 something and a 50 something. Okay, so all I'm doing is kind of trying to get these runs for these signals at roughly the same length. Okay, that all looks fine. If I come over here, I want to come in with my DC barrel, and then I need to get down here. This is the only place this goes is right here. So I want a nice thick trace here. So I'll do a Shift W for a wire, Alt W for a wire, Shift W to pick the size. And if I do a 1, and that's how big it is. I've got room to go bigger, so I might as well Shift W. 2.54 is maybe too big. So I'll maybe just go with the 1. And if I look at the coming from the USB and I do a 1, that's way too big. If I do a 0.5, not bad, 0.75, that doesn't work. So 0.5 it is. So I'll run that to there. And then from this 5 volts, I have a bunch of places I need to go. And I'll probably run that with a nice thick trace. So Alt W, Shift W to pick a size. And let's go 2.54, too big. So do I want to go with a 1? Or something in between. So let me just go in between here. And these are the ones I have. Maybe I'll pick a 1.5. So let me add in here 1.5. And I'm going to move that up. So let's go see what that says. It's saying the 100 already exists. Okay, so I've got it. I don't know why that's in there twice. I didn't do that. Okay. This looks decent. And so now I'm just trying to see, where all do I need to get this 5 volt run to? Okay, so now I've got to get 5 volt over here. Okay, so it looks like I'm just missing one way down here. Okay, let's save. and get some of these others put in. So the grounds I'm not going to worry about at the moment. Again, they'll use the plane or the bottom fill, assuming that I don't do any routing on it. And so far I'm doing all the routing on the top. I don't know if I'll be able to keep with that, but that's what I'm trying to do. Here we have a button, and it would be nice. Maybe I can pull this down. What I want to be able to do is run from here to there, and I have a ferrite. I suppose I could run underneath that. So this switch, I'm going to have to get up there to that way up there, and I'm going to start with a thinner. And so this is still a 0.254, which is plenty. These are all this 5 volts, so I'll do a wire, and let's see, how thick can I go on that? Okay, so now here, I need to get from here down to here. Again, I'm trying to keep all the routing on the top layer only. And I think a good way that I could, maybe kind of cheat this a little bit is to put a 0 ohm resistor here that I could run it through. That'll let me kind of jump over these. So I think that's what I'll do. Let's go find this one here. And I'm going to put in a very similar way, 0 ohm in here. And actually, let me delete this. Okay, so now what that's going to let me do is get this wired up like so. Okay, that should be good. What do we have left over here? I have a chassis ground and chassis ground, and that eventually gets down through these components, which again, one of these was a do not populate, and that's probably this resistor here. Yeah, right there. And then I have this capacitor. So those are going to ground. And I need to connect all of this up. And question is, can I get this routed to that chassis ground? I suppose what I could do is come in here and bring this around. And need to do some cleanup because that's pretty ugly. Okay, so I've only got 2 signals left, it looks like. However, I have this big mess in my way. I need to get this around the other side of this, if at all possible. But I think that's going to be tricky here. So I'm going to delete this segment of this and this. And so somehow I've got to decide how I want to connect that. And I think I have some choices. And what is this going to? It's going down to a header, not crazy important. And maybe a reset line, again, not crazy important. Maybe what I'll do is delete this here and here. And I will get this routed up and around. It seems like I could come up here and do this. Okay, so that might not be the prettiest thing in the world, but there's my, the 5-volt coming in that basically is running around the board that way. As far as the IC is concerned, it's using this filtered, which goes through this ferrite, which is tapping in right here. So power is going to come in. I have a bulk capacitor. It's going to route up here, and then from there get down and power my the main MCU, along with getting power over to these. And so that all seems reasonable. So now I want to run these signals. I've got 2 signals here that need to get, okay, that one's on bottom, this one's on top, which isn't great. And I guess they do cross over here. So I've got to get that routed creatively. Now, seems like this could move. I got room for bringing this up over here. And I'm just trying to give myself a little bit more room. Okay, for these signals. Now what I'll probably do here is do a route and a differential pair equal tuning. This is going to be interesting. So there's one. Now this one, though, I've got to get around the back of this. So then the question is, where do I want to get through here? And there's really not much room to get through there. So I've got chassis ground in the way. I'm going to pull this down to 0.127, and I still can't get through there. So that's a problem. So instead of doing that, let me come on the other side of this. So I'll come around through over here, if that's possible. Okay, maybe not ideal, but I think that's going to be fine. Let me get my other connections here. Okay, so now I'm going to have another challenge that I need to go and connect this to here, and at the same time get this one connected over here. So I'm probably going to jump this on the bottom layer. So I'm going to hit B for bottom layer, or Alt B, and go like this. So again, I don't know if I would say that's ideal. And see if I can get this in a little bit better position. So then the question is, can I get this signal from here to there, taking it a different route? I'd have to be able to fit between here, and I don't think that's going to work with there's just not enough space. So I'm going to take this little tiny piece on the bottom layer, which is fine. What you don't want to do is be cutting up that bottom layer since it's a ground. I'm trying to use it as kind of a ground plane. I do see I need to connect this up here, so I'm going to hit Alt-T to go back to the top layer. This is just a power indicator, but let me get that like so. Now what I want to do is try to get these two to be equal length. So 55.5. Oh, and actually they're amazingly close. So I might actually be okay there. So this one is 55.2. This one's 55.4. And I could probably get rid of that just by even pulling this in just a little bit. There we go. So 55.4 and 55.2. Now maybe something that might be even better than the way I have this is I'm going to move this over here. I'm going to delete this and this. And I'm going to pull it underneath over here. Okay, so I'm going to do the Alt-A or Shift-A and make one of these a little bit longer. So 58.4. So this needs to be lengthened a bit. So 58.4 and 58.5. So it should be good with that. Now, if you want, you can have the system, when you do your DRC check, actually check to make sure those are all set up correctly. So you can go into your design rules, and you've got all kinds of rules you can set up. And I might come in here and look at things like spacing. So what are the space, what kind of space do I need here between like track to track? I need a 0.1 minimum. And this is set up for JLCPCB 2-layer. So that's what I'm doing here, kind of a top and bottom. They do have truly a single layer board. And then they also get into these other setups that can do, tighter tolerances. But if I get into here, I can do differential pairs. And I can set up rules for those. I believe I need to come up here. Design differential pair manager. And so I can come in here and maybe say that this is my USB differential pair. And that would be my DP signal. And then the negative would be the DM signal. And I'm just looking at that over here. Okay, so I now have that set up as a differential pair. And so again, if I went into design differential pair manager, I now have a differential pair set up so that DP and DM will follow the rule that differential pairs follow. So this is giving me my stroke width minimum, my default maximum, spacing, and tolerance, so the difference in length. And that way when I go to do a check of my DRC. If these are out of spec, it will warn me. I'm not going to do that with anything else. I don't think anything else in here is really, I'm too worried about distances. Okay, am I missing anything? That's the question. So let me hit a save. And I'm going to go down and do a DRC. And I've got a bunch of, I can see copper region issues. And that'd be because I've got this copper region on the bottom, but I've now routed some stuff around. Maybe I have some things up top. So I would need to rebuild all my copper. And I do a Shift B to do that. And that rebuilds my copper. Now I can also come back and click on like this bottom copper region and say rebuild region, but I just do a Shift B that does all of my copper rebuild. And then I want to check the DRC again. And at that point I have no errors. So something else I might want to also do is on the top layer, fill it. And I could fill it with ground, or I could fill it maybe with this 5 volt. And that way I get a nice clean 5 volt distributed everywhere here. And so to do that, I might just grab this bottom one, copy it, basically place it over, but set it up as a top layer. And instead of as ground, I want it to be my 5 volt filtered, or just 5 volt, actually 5 volt. So like so, and then I'll do a Shift B to rebuild everything. So now it's going to end up, you'll see that like this chassis ground going through here has space between it and the fill, because this fill is 5 volt. But all of this stuff that I ran actually has all of this other copper all around it that is 5 volts. So I've got 5 volt, filling this all pretty well. It's going to, not make it around. Well, yeah, actually it would. Yeah, up here, this is going to fill in. This would all be 5 volt on the outside edge. Plus it's coming around all the way this way. So I've got a pretty good, probably 5 volt fill on the top. And I've got a ground fill on the bottom. I have this chassis for my shields connected down, going through this capacitor down to my ground for the board. If I look at the back side of this, I did an Alt F, which does a flip, so I can look at the back side, and the only place I really got into that a bit was over here, but I can see it's not going to fill into that anyways because of the tolerances, so that's all perfectly fine. So I've got a nice bottom copper fill, and I'll do an Alt F to flip it back up to the top. I'm going to just double check my DRC one more time, and I'm going to go to a 3D view. So this is how it's starting to come together. Now that I've done this, I kind of want to move that a little bit. Okay, serial connection, power connection, USB-C, just for basically to be a USB device that I can plug into a different host. Now I do think you want to keep a certain distance from like these differential pairs, any of these high-speed lines when you do the fills. And I could probably go look at my DRC rules. Copper regions, I think at 0.254 I should be good on all of this. I don't have any inner planes. Yeah, I think I'm fine with all this. Okay, so this is probably to the point then that I could see what it's going to cost to build these. Now, maybe I can move all of this and kind of, move this down. And I did a quick rebuild of my copper. Let me save it. Oh, let me go ahead and I always get a little over DRC happy, so check that out, and yep, all good there. One last spin around it in a 3D view. Now, a lot of scrutiny could go into what size traces do I really need here. All of these traces are way more than I need, so some of them are thicker than I need by a long ways. You can decide what makes sense for you. So 0.254 is what I use, like when I come down even to these just standard type of port connections. In some cases I went thicker or a little bit wider, but you could take all of that down to a 0.254 and be fine. Now, maybe up here, though, I have a little bit of a concern. So there is a box here that's trying to do a copper fill, and I do have copper around this, but I'd like to have this be ground copper fill down here. So an easy way to maybe fix that is just to do a via, so Alt-V, and get this connected. So if I put a via in here, it'll connect the copper on the bottom side, and I could probably do the same here. And then I'll do a Shift B to rebuild. And so now you can see that those got filled in with ground. So I've got ground here, ground around all of this. We got these signals coming down here. So that just kind of filled that in with ground a little bit better. That is probably the build there then. Now let's see how much is it going to cost to actually order this PCB. Okay, so I'm going to run through the settings. 2-layer, for all practical purposes, could you have gotten away with a 1-layer? Pretty darn close on this. But it is a 2-layer. I've got all the routing on top with one tiny exception, which is over here. If I had to bring that up to the upper layer, I'm sure I could find a way to do that. But that's the only place that I'm dropping really that trace to the bottom. I'm going to order 5 of them. Standard 1.6 millimeter thickness. Colors, I can pick what color I want. Let's see if they're adding a charge for that. And in this case, I'm not seeing an extra charge for the color. So it seems like they've been changing maybe how they do pricing. Green is the fastest though, so I'm going to stick with green. Silkscreen white, 1 ounce copper. Tented vias is fine. I don't have any vias smaller than 0.3 millimeter, I don't think. So I could go back here, and really trying to say, are any of these smaller than a 0.3 millimeter? And this one you can see is a 0.8. So, it's very large. What is my smallest? I'm sure it's going to be over here. And I can look at that and see that I'm at a 0.4 millimeter diameter. That's for the hole, and then 0.65 for the outer. And so not even coming close to having to go to a smaller, like right here actually, smaller minimum hole size. If I had to do that, that'll increase the price, but this board doesn't require anything like that. Okay, I do also notice my dimensions is over 100 wide. I wanted to stay within 100 by 100, so I'm going to trim that down. I should have paid attention to that earlier. So I'm going to come in here and see if I can't get that trimmed down a bit. I think I can do that. The right side looks like it's going to be more sensitive to me trying to shrink it than the left side. So I think I'm going to get rid of my fills. And let's see, filter. Let's get rid of viewing the copper. And I need to pull this in, not much, but a little bit. So let's see, width right now is 103. That's 102. That's 100. Okay, so that's what I've got to get this shrunk by. Let's see if I can do that. Gonna rebuild my copper. Definitely do a DRC check. Let me do my 3D view again. And so in this case, you'll notice that those connectors I have sticking out just slightly, but that is not a big deal. There's plenty of space here for the way I've got those soldered on, so I'm comfortable with that. Okay, and what you'll notice is there's no engineering fee anymore, so that pulled $4 off because I stayed within this 100 by 100, I believe. And so at this point, I could get this ordered up. Shipping, I can change that to a more affordable option, but you can see that the PCBs themselves really, at least for this order, $2 for 5 of them, so very inexpensive. And then I believe the least expensive shipping, let me just see if I can maybe go take a look at shipping options. And actually, yeah, I can do shipping right here. And looks like all the way down to $1.50. And pretty slow, 8 to 13 business days. But if I pick that, you can see that I'm down here at pretty low price. I don't know why it says uploading my files, but let me go to my cart. So instead of $4, got a coupon or something for $2. So $2, $1.50. So I'm at a subtotal of $3.50 for 5 of these boards. So I think that's where I'm going to stop this video. I will likely post a part 2. I'll go ahead and order up these PCBs. I'll get a set in and see if I can put together the PCB and program that MCU and see if I can make it do something. So watch out for a follow-up video, but hopefully this video was enough to kind of see my process that I was going through. If I do go back to, let's just say, this blog post, what I'm doing now is recording this video that I'll post here as creating the schematic and the PCB. What I haven't done is maybe prototype the circuit on a breadboard, for example. I'm going to kind of skip that step. I think this is simple enough to let me do that. Update the schematic of PCB based on anything I learned from that. Prototyping, order the PCBs and the components, assemble it, try to program it, test it, etc. That's really what the next video will be, which will be part 2 of this. So I made it through the schematic side of things. Initial schematics basically sketched out, and then I've jumped to having this schematic built out with the PCB ready to go. Good enough. Thanks for watching this. If you have comments to share to help others, feel free to drop them down below. Hopefully this was just enough, maybe not a perfect board design, but enough to give everybody the idea of using EasyEDA Pro to get in and do this.